the very fact that this hall is full on a Saturday at lunchtime shows how proud all of us Indians were when India landed, the Chandrayaan 3 on the moon. I remember that I was glued to my desktop, watching the ISRO site. They had a live telecast, so I'm sure most of them were also doing the same. And so I really, actually, before we go further, let us give a whole round of applause to ISRO and all the institutes who were actually involved in doing this. And a big thank you to the Raisoni group and all the organizers for giving us an opportunity of interacting with Dr. Lele, who will tell us more about, the build up to this historic event. It was 23rd August when India's scripted history. And Dr. Lele has written a book on Chandrayaan 3, the India lands on the moon. So very quickly, I would like to ask him to tell us a little bit about his journey to this book and a little bit on the origin of India's space program. So, Dr. Lele.
Thank you so much and good afternoon to you all. Thanks a lot for standing between your lunch and my talk, but still you are here. So it's great to see you all. And you see, at the end of the day, it's the young minds who are going to take forward India's mission to science. So it's good to have such a young audience over here. As far as my understanding of space is concerned, as you must have heard Madam giving a very nice introduction about me. The thing is that I'm a slightly confused person, in a sense that I did my master's in physics, did my PhD in international relations. So at the end of the day, I don't look at a science only from gamma, theta, and all those types of equations, but try to look at a science from a public perspective, from a perspective of a policy. So that's the basic idea of looking at a science. When India was planning to do way back in 2011-12, there was an idea that India will go to the Mars. So I don't know why it clicked me. I just went to ISRO website, wrote a mail to Chairman ISRO saying that I want to do a book on India's Mars mission, which you're going to undertake. And to my utter surprise, within 24 hours, I got a call from Chairman ISRO, and he said, "You come to Bangalore, I will give you all the information." So the book which I wrote on India's Mars mission actually pushed me to look at India's space program more deeply. Subsequently, I did something on ISRO only. The Rupa publication, which has published this book, they had pushed me to look at ISRO as a wholesome game, because my background is essentially from defense. So I used to look at issues more from a very narrow perspective of a defense. But it actually dawned on me that ISRO has done such a wonderful job as far as space is concerned. So coming to your question, how all this started, it is said that way back in 1964 particularly, when Tokyo Olympics were happening, those Olympics were live directly in the United States of America. And that was the first time when a live telecast of a games being played was done. Dr. Vikram Sarabhai, whom we all know as a father of India's space program, it clicked to him that this is the strength of a satellite technology, that from Japan all the way to USA, in a real time, you can project what is happening over there. So he understood that there are two technologies which are of great importance. One is a communication technology, that is what the satellite technology brings in. And other is the strength of a television. Because his view that at that point in time was that let's educate the masses in the country. And to educate the masses in the country, you have got India, a country which is more of an island sort of a country. You got places like cities like Delhi, Mumbai, Nagpur and all that, where a lot of educational institutes are there. But there are no educational institutes in far-flung areas. So he got an idea that if we can use communication technology via satellites and use televisions for the purposes of education, then it will be a great idea. So that is the basic, what we can say in today's word, the Kida which got into the mind of Sarabhai, and he started working on India's space program like that. So this one can say is somewhat the origin of India's space program. Subsequently, it so happened that India being a country which had just became independent, there was various areas of science and technology which already had started working. In fact, you'll be surprised to know that Indian Institute of Sciences and other institutes had come before independence only. So there was certain amount of a background of looking at a technology from a policy perspective, from a perspective of looking at things, whether it will help the India's population to get out of the tag of what one can say Garibi. So he and few other scientists, they were ably supported by the leadership of Nehru at that point in time, started started arguing that as far as technologies are concerned, it's not only a domain of the major powers or the people who are rich. Because India never looked at a technology as to do something to impress somebody else. India looked at the technology for the purposes of a socio-economic development. So in those days, there was always an idea that if India is a country which is an agriculture economy, then you require a certain amount of technologies which will help you to carry forward the idea of agriculture in a very scientific and a systematic fashion. So the basic issue as far as agriculture is concerned is the weather. So initial investments of India's space science and space technologies was in two major areas. One is a meteorological satellites and other is a communication satellites. So India identified 2 to 3 key result areas where we want to use this technology. First was for the purposes of agriculture. Obviously the meteorological satellites were there. Then for the purposes of what we say connecting with the masses for the purposes of education, communication satellites were required. Then if you see India, India has got one of the most difficult geographies all over the world. Why I'm using the word difficult geography is because at one point in time in places in Rajasthan, you got temperatures which will be plus 60 degrees Celsius. But you go to Kargil, Dras and all that area, the temperatures could be as low as minus 50 degrees Celsius. So we are a country which is peninsula. So you are affected by cyclonic storms. We are a country which has got deserts. We are a country which has got Himalayas. You got a country where you go to the northeastern parts of the country is thickly vegetated. Then you got rivers which are as big as seas only. So under those circumstances, you require a technology which will give you how to manage all these resources. Otherwise, what used to happen is that I have got a small farm. Nighttime, I will just extend the border of my farm and I will take over the farm of my neighbor into that. So all those types of small things were happening. So you require a technology, what we call a remote sensing technology. So when we are talking of a satellite technology, India started making investments into 3 to 4 core areas. One is a communication, that is for the purposes of education. Remote sensing, that is basically to understand how you can manage your resources. When I'm using the word resources, I'm talking of land, I'm talking of jungles, I'm talking of water resources. And then you have started developing these technologies in a very systematic fashion. And over a period of time, the focus shifted. Many people are actually not aware of it on telemedicine. We have started using because the same idea that we have got doctors in cities, but how about the villages? So again, the satellite technology has been beautifully used for the purposes of telemedicine. So this is in short what one can say.
Yeah, thank you,
how India's
sir.
space
Actually,
program
I
has
was
evolved.
actually coming to this communication sector because we have say 99.99% of the people who are really proud to because of our space program. But there are still, 0.01 of the public, everything will never be consensual. So there is still that part who says, why should we put so much of money into space research? And, it was 1969 when man landed on the moon. And so are we, going to the moon and are we having cafes there or are we having colonies there? There is some small percentage of people, who think like that. Although Elon Musk did plan to go and have a visit, but yeah. And so when it comes to me, then I tell them that yes, in 1969 they landed there, and we haven't really gone and colonized the moon. But look what it did to the communication sector. So you already gave us outside communication also there is so much. Can you just tell us about Chandrayaan 3 mission? What would be the benefit to humanity? I'm not saying restricting it only to India, but to the rest of the world also. So these kind of missions, how do they actually help us?
Definitely. you see, those of you who have done certain amount of, very sorry that I'm getting back to my defense hat, who would have done certain amount of reading, that there has been a debate which is happening worldwide, guns versus the bread. So people are saying that why you're investing so much into all these high-flying technologies. Here I'm not talking of a guns, but again the technologies, that what use of going to the moon? Somebody has gone way back in 1969. So why we are doing it today? So I think one has to look at these things in a perspective. What happened is that, I'm sure you people understand that there was a period of a Cold War where two major power blocks were at the throat of each other and fighting with each other. So when we are talking of a Cold War period, it was the nuclear weapons which was dominating the entire discourse during that time. So who has got more nuclear weapons becomes a solid power. So there was a something like technological one-upmanship at those point in time. If you go back to the history of a space, it doesn't have much of a history, in a sense that the first satellite was launched only way back in 1957, the Sputnik satellite by the erstwhile Soviets. Subsequently, US realized that the Russians or the USSR that time has got a technology which is such a good technology that it may help their nuclear capabilities more. So it was at their back that something is to be done, because it appears that the Soviet Union is defeating us in the race of a space. So immediately the US launched their own satellite. Things were okay till that time. Then it so happened within 2 years, the Soviets planned a mission of a human to the space. I'm sure you must have heard the name of Yuri Gagarin. So Yuri Gagarin became the first person to go to the space. Actually, when he went to the space, it dawned onto the US leadership that we have been totally defeated in the race of a technological one-upmanship. So we have to do something which is so mind-boggling that the entire world will understand that it is not the Soviet Union which is a leader in technology, it is the United States of America which is a leader in technology. And trust you me, that is the only reason why Neil Armstrong went to the moon. Because if you really follow those periods, you're too young to, but if you're seen nowadays, everything is available on internet. Hardly, uh, I think only 12 people reached to the surface of the moon. Subsequently, the missions were not taking place. There were two basic reasons to it. One is that it was a very costly affair. So US also understand that they can't go to the moon every now and then. And more importantly, there was no science agenda to it. It was more of a political agenda of making a statement to the world that we are so great as far as space is concerned. But now, over a period of time, people have understood that it's not a fancy to have a colonization of the humans on the moon. The idea is that today she comes from an environmental background. She will be able to speak much more on that, about the issues of resources. The resources on the surface of the earth are very fast depleting, and they are finite resources. When I'm using the word resources, I'm talking of minerals, materials, right from say gold to aluminum to everything what you can stock of minerals and materials is almost getting over from the surface of the earth.
Also, water, air, oxygen.
Yeah.
They are also finite.
Uh, then the issue which comes up is that I'm sure you must have read in newspapers something which is known as RREs, that is rare earth elements. Now, those elements are mostly available in China. Otherwise, they are not available. When I'm using a word in China, that means within the earth below China. Now, why these things are important? You all know that all your mobile sets, all your computers, everything is about semiconductors. So when you develop a chip, you require all these minerals and materials. So if those things are going to get over, what we are going to do about it? Can we have certain amount of alternatives? So people started looking at the other planets, and they understood that these planets have got good amount of resources out over there. Now nobody is saying that the world's resources are going to end today, but if you know that the resources are going to end after say 5 decades, 6 decades or something, you have to start doing something today. So don't look at the moon program and a Mars program that what it will do to me tomorrow. These are very long-term programs where you're looking at those things. One more interesting aspect as far as the moon is concerned is that there is a component or a material one can say called helium-3. Now what happens is that when you're today creating energy, You use solar energy, you use biofuels, you use various types of energy generation methods. One most important energy generation method is a nuclear energy. So India has got tremendous amount of investments which have been made into nuclear energy. So you got what they call fusion reactors and all that. So your energy generation is based on what? Energy generation is based on certain amount of materials like thorium, plutonium and all that. So if you want to replace those materials by using a helium-3, the theoretical calculations say that if you can get one aircraft load of a helium-3 onto the surface of the earth, it will resolve the challenges of energy for almost 10 years for the entire world. These are theoretical calculations. But then we started looking at helium 3. Then we realized that on the surface of the earth, the presence of a helium 3 could be even 0.00001%. But on the surface of the moon, the helium 3 is in abundance. So, can you get those resources over here? So, getting those resources is a very, very challenging task. But you have to start today. Maybe then your children or your grandchildren may get benefits out of it. So don't look at a space technology as a technology which is helping me today. It's a very long-term investment.
Thank you. Yeah, that was very nicely explained. We have never thought in that direction. Actually, I personally never went beyond the communication sector. I didn't even think of this, minerals as another source. But there is one concern actually, that I have, and I'm sure others do too, is this space debris. For one fruitful Chandrayaan 3, and this is only just India. So across the world, there are so many who are doing. There will be so many failed missions. Now all that is, junk in the space. So we've already polluted the earth. So are we going to now pollute the space? What are your thoughts on that?
I think you have brought a very relevant and a very important issue which is not often discussed. When we are talking of a space debris and polluting, we have already started polluting it. I will try to draw your attention of a very sad incident of an Indian origin astronaut Kalpana Chawla's death. I'm sure you all must be remembering it. It so happened that her spacecraft was coming from the International Space Station towards the Earth. And at one point in time, the spacecraft got blasted. It so happens that as you try to enter the Earth's atmosphere, trust you me, the temperatures can rise to the level of almost 3000 degrees Celsius. So, all these spacecrafts which are sent towards the moon or towards the International Space Station and whom we expect to get back into the Earth's atmosphere have got something which is known as a thermal shield. So, this thermal shield is one of the most important element of any sort of a human space mission. Because other space missions, you just send an aircraft and it remains over there. But for humans to get back, you need to have a proper thermal shield. As far as Kalpana Chawla and I think around 6 to 7 more astronauts died in that mission, because as they started entering the Earth's atmosphere, the thermal shield broke and everything got evaporated. Now, why I told you this story of a thermal shield is that as there is a debris in the space. Now, what is a debris in the space? There are artificial ways of creating a debris and natural ways of creating a debris. So, comets are there, various other things are there, which are there in the nature where we do not have any sort of a control. But when you launch a satellite, I'm sure you must have read in papers or must have seen on a TV that a satellite launch, that is a rocket launch, has got various phases. That is, the first phase is over, second phase is over, third phase is over, and now the fourth phase is over, and a satellite is launched into the space. So what happens is that the first phase, second phase, and all that, they come very close to the Earth's atmosphere. So they start melting down and nothing happens. But the fourth phase remains out into the space. And since there is no gravity out over there, it continues to linger around. So today I'm launching one satellite. The last stage of my rocket ends up becoming a debris. Tomorrow she is launching a satellite. The last stage of her satellite ends up becoming a debris. Then my satellites have got a definite type of a lifetime. That means it can stay there for, say, which are the low Earth orbit satellites, they may have a life of 3 years to 5 years. The higher orbit satellites have got a life of 10 to 15 years. But after the life of that satellite gets over, it ends up becoming a debris. Now, all these debris keep on circulating in the sky and they keep on hitting on each other. Because you see, when I'm launching a satellite, it has got something which is known as a fuel. So based on that fuel, by giving instructions from the Earth, I am able to manage the activities of the satellite. That means it is at this particular orbit. If I want to change the orbit, I will give some instructions. Some amount of fuel gets used, the satellite will be changed into other orbit. But when the fuel gets over, the satellites become dead. Now there is no control on that satellite. So it is not moving in a specific fashion. So it becomes totally, one can say, aimless. And it gets on hitting on each other also. This idea came out by a scientist called Kessler, and it is known as the Kessler syndrome. So that by hitting each other, the satellites continue to create more amount of a debris. Now, from a military perspective, why these things have become very pertinent now? Because in the year 2007, China did something which is known as an anti-satellite test. That means they demonstrated that we can send a missile from surface of the Earth and destroy a satellite. They use their own satellite only to demonstrate this capacity. Now, why this anti-satellite test is required? From a military perspective, your enemy has got satellites, and tomorrow, suppose war happens, you want to give an indication to the enemy that this is what sort of a mechanism which I have got. If a need be, I can destroy your satellite. But by destroying a satellite, what China did was that they ended up creating tremendous amount of a debris. The satellite was destroyed at an altitude of 800 kilometers. But subsequently, India in the 2019 also did a similar type of anti-satellite test. But India played it very smart. India destroyed its own satellite at an altitude of 280 kilometers. So at that altitude, whatever debris was created, that has come down because of gravity, enter into that high temperature zone and has melted away. So if you do these types of aimless anti-satellite tests, just to demonstrate your military capabilities, you end up adding into the debris. And that's why there are significant amount of debris which are there. And to identify those debris also, you require certain amount of a mechanism. We call that as a space situational awareness mechanism, where a lot of radars, telescopes, everything is there. So there are debris which are numbered. United States Air Force actually undertakes that activity, but one has to really look at global issues about that. But we'll talk about it some other day.
Yeah. So now a question that we see in a lot of movies also, about aliens and things like that. I'm not going to that extreme, but when the Earth was formed 4.5 billion years ago, so the microbes were the first form of life, and mainly the bacteria. And today, 4.5 billion years later, the bacteria still exist, because they have adapted through all that. Yeah. We have seen so many eras, like say the dinosaur era, they got completely wiped out, but microbes survived. And so, is it possible, that there could be microbes in other planets? Because, I have read somewhere that, say, Jupiter and Saturn are like filled with methane. But we have methanogenic bacteria. We have bacteria that can use oxygen. We have bacteria that can live as anaerobes also. So, do you think there is some possibility that microbes exist in other, planets or moons?
You see, there is a lot amount of a research which is happening. I do not have a specific yes or no answer for her question, because actually nothing much is known. But as far as space microbiology is concerned, there's tremendous amount of research which is happening. As far as astrobiology also is an area where people are looking at planetary issues and all that. Now the issue over here is 2 to 3-fold. One is that I'm sure you already must have read that China has got their own space station. We have got an international, the entire world, 16 countries, US, Russia and other countries have joined hands together and they have got an international space station. So humans are staying in space for quite some time. So one aspect is that, are they transporting some bacteria, at least they're out into the space, and are they surviving over there? Already experiments have started happening where people have started growing vegetables into the space. So definitely there is a cause that humans only will transport certain amount of bacteria or microbes out into the space. That is one way to look at it. But that is very early. But there have been certain amount of indications that there could be certain amount of microbes and bacteria available out into the space. There are some studies which are available where people have proved, but it is difficult at this point in time to prove the origin of them. That means whether they were human transported, whether they were existing already over there, come from some other planets. Because you see, you got a lot of asteroids, comets, all those things. There is tremendous amount of activity which we do not know is happening out into the space. And when you are having, you see, I'm just slightly digressing over here. Couple of days back, Elon Musk had sent around 49 satellites into the space. And within 2 days, 40 of those satellites became unserviceable. This happened because of the solar winds. So solar winds, there is a lot amount of ionization which takes place. So it impacts your electronic systems out over there. So there could be a possibility that because of solar flares, because of other related things which are happening out into the space, certain amount of microbes or bacteria could have come. In fact, when SARS happened, the COVID era, people had started actually trying to think that is the basic virus, has it come from the space also? So people are trying a lot amount of research, but there is no concrete answer as of date that whether the origin is there or it's a human-made
Yeah,
origin.
till then we rely on the movies for information.
Exactly.
We had Martian, if you remember
Yeah.
that movie, which was so interesting. I think before our time runs out, let us talk a little bit about our solar mission. I think it's
Yeah.
Gaganyaan, right? So
No,
now,
there are two missions. Gaganyaan is a human mission. Solar mission is a Aditya L1.
okay, so can we a little bit talk
Yeah,
about the
sure.
solar mission, because we have understood what now the moon missions can help the humanity, but solar is a little
Yeah.
difficult to understand.
I
So
understand.
can we do that?
You see, now what happens is that I've already spoken about Elon Musk losing 40 satellites in a day. This all happened because you see, you got, if you know the structure of an atmosphere, you got a troposphere, you got a stratosphere, you got a thermosphere, you got ionosphere and all that. So if the properties of an ionosphere get changed, it impacts your atmosphere. And immediately what it impacts is impact your electronics. And the first thing to get impacted is your satellite systems. And that's why when solar storms happen, when something goes amiss into the sun, there's something which is known as a solar cycle also. It gets repeated after every 11 years and all that. So there are a lot amount of activities which are happening out into the space because of the activities which are happening on the sun surface. Now, what happens is that over a period of time, you had very limited satellites into the space. Today, when we are talking of launching of satellites, particularly you see space-based internet, this idea came into being only in the year 2019. Before that, these ideas, these structures were not there. So you will have some 5 satellites launched by US, 15 satellites launched by other country and all that. But now if you see, thousands of satellites are getting launched. So under those circumstances, you need to know more about the space weather. And as far as space weather is concerned, the only source for creating what we call a space weather is the sun. So you need to understand something about the sun in a greater detail.
Okay.
And that is the reason why India has planned a mission called Aditya L1. Now L1 is, I'm not getting into the technical details of it, but L1 is a Lagrangian point. So a point where you can say the gravity of both the planets cancel each other. So at that particular point, the satellite can remain in a stationary fashion and continue to take observations. Otherwise, what happens is that if you got eclipses which are happening, the satellite loses the visibility to the sun. So under those circumstances, you need to find a point where the satellite can continuously monitor the activities of the sun. So India has already started doing a lot amount of activities as far as making investments in the space domain, not only for communication, navigation and all that, but from a point of view of a science also. Because we need to understand our planet. And the moment we started understanding our planet, we have started realizing that it's not only our galaxy. You must have read from Hubble telescope, now you got a James Webb
Yes.
telescope also. There are a lot of other galaxies also. So I'll give the same argument which I was giving. Don't get carried away that today India has sent a satellite to close to the sun. Immediately I will get certain amount of benefits. It's for the long-term perspective. It's for a basic understanding perspective. Because if I want to predict the space weather, or if I want to predict the activities of the sun, I need to have an observatory which will at least give me certain amount of readings. Based on those readings, I can do certain amount of a mathematical modulation. My understanding of physics gets into it and all that, and then you process it further. That is the reason India first launched a mission called AstroSat, where we started looking at the galaxies, at other planets. And now we are already launched a mission, but it takes time to reach to those distances. So we already launched Aditya L1 mission, and as of today, the mission is totally on track. So I'm sure by January we will have our satellite, which will be now looking at the sun also.
Yeah, amazing, extremely interesting. So, actually, 40 minutes is really not enough to cover this really interesting topic, but time is really ticking away. So, I will just ask you to take the last few minutes to tell us a little about this Gaganyaan.
You see, as far as India's foray into the space to carry the humans, it started way back when Rakesh Sharma went to the space. He went to the space courtesy Soviet Union. Soviet Union told India that yes, we are ready to send your astronaut out into the space. Of course, it was a quid pro quo sort of a thing. They wanted their radars to be positioned somewhere, but India took that as an opportunity. And we all know that the historic answer which Rakesh Sharma gave, that how India looks from the world. Sare sa se acha. So after that, there was a total lull as far as these activities are concerned. You see, if you really look at India's space program, it is one of the most thoughtful planned space programs. Our initial focus was, like I said, communication satellites, remote sensing satellites, satellites for the meteorology. Subsequently, we realized that GPS is getting a lot amount of a clientele. So we decided that we will invest into navigational satellites also. So India came out with a regional navigational satellite system because to have a system as comparable or parallel to GPS, you require more than 24 satellites out into the space, and we do not have that sort of a financial wherewithal with us, at least at this point in time. So we decided that let's start small. So we have launched a system called Navik, which is 7 to 8 satellites for a regional navigation. So we started doing all these increments step by step. You see, Moon program, Mars program, Gaganyaan program, they are getting talked in media with a very high fashion things. But if you look at ISRO's budget, hardly 5 to 7% of ISRO's budget is used for all these programs. So after Rakesh Sharma, India decided that yes, now the time has come where India also needs to go out into the space to undertake a human mission. Because of a COVID crisis, that mission has got delayed. It may take another year plus time for India to send its own astronaut out into the space. Before COVID period, we had identified the Air Force officers. They had gone to Russia. They got trained as astronauts also. But India making its own spacecraft and developing an entire human program got delayed because of COVID. I'm sure you must have recently read that we have undertaken the first mission, which is known as the astronaut rescue mission. Because sending a robotic mission, in a sense, is very easy. But sending a human to the space, right from your food to your bathrooms, everything needs to be thought of.
Right.
So it's a very complicated and a critical mission. India is doing it in step-by-step fashion. India has got an ambition of having its own space station. To have your own space station, you will have to have your own scientists, own astronauts to go over there. So again, this will take another 10 to 15 years of a journey, but we have already started making investments into human space mission like this.
Yeah, simply amazing. I wonder who will be the next Rakesh Sharma to, go in the space. So, do we have time for one more question? Or we're almost done. Okay. So, just a very quick comment from you. So, everywhere in media, social media especially, and also in the newspapers, they keep saying, the space race has begun. The race to space has begun. Everywhere they are using the word race, and I feel it has a negative connotation to it. I think we humans are already, badgered with the rat race. Everyone's life is like a rat race. And now you want to have space race. What are your take on that?
I think it's an interesting question. If you ask a rat race, I am all for rat race. But even if you win a rat race, you're still a rat. So one has to really understand that whether you should unnecessarily get into these rat race or not. As far as space is concerned, there has been a continuous talk. You see, every country wants to go to other planets and manage the resources over there. So there has been a talk that people are in race. But one must understand that what are the requirements of that country. At least to my limited understanding, India is not trying to get into any sort of a race. We don't want to prove the other countries that we are better than you, because this is a very stupid idea as far as space is concerned. I'll just take a minute over here. The idea of a race came during the Cold War period, which I again explained in the politics. It was supposed to be an arms race. That means USSR has got 100 nuclear weapons. USA said, I got 120. Because you see, at end of the day, you may have so many nuclear weapons. You only require one nuclear weapon. So when you're talking of a word deterrence, it's not that whether somebody has got 1,000 nuclear weapons is a better power than, say, a North Korea which has got, say, 5 nuclear weapons. That doesn't happen. But people don't understand that and unnecessarily start pushing. And you know that disintegration of USSR happened because of unnecessary investments into arms. And we don't want to follow that route by unnecessarily saying that, oh, China did this, China did that, so we also want to do it. We will do what is required for us. And we are going, to my understanding, in a very systematic fashion in the domain of a space.
Thank you so much. And I think we'll end here.
Thank you.
We had a wonderful time chatting with Dr. Lele, and he gave us so much of information that we did not really have before. I would urge you all to read his book, Chandrayaan 3, the India lands on the moon. It's extremely interesting. I've gone through it. And I think I will just end by saying that all of us as Indians, we are extremely proud of India's space research, and very honored to have Dr. Lele here to come and tell us a little more in detail about it. So thank you.